Okay, you've been introduced to the imaginary number system, and the base of the imaginary number system is the number I. Now, we need to connect that with what you've already learned. Before today, or before this unit, you only knew about real numbers. Now, real numbers are numbers that you've always dealt with. Numbers like 3, that's an example of a real number. 5.7, you've dealt with decimals before, and that's an example of a real number. If I had the quantity 5 minus 7, in my head I can do that math and get an answer of negative 2. That's a real number. That's an integer. It's a negative number, but it is a real number. Negative 2 is an example of a real number, like we just said. The square root of 7. That's also a real number. If we punched in our calculator the square root of 7, we'd get a decimal value that is irrational, but it is still a real number. Therefore, pi, the value of pi, which is 3.1417, the ratio of the circumference of a circle to its diameter, is always an example of a real number. The new numbers that we've talked about are numbers that involve the quantity I. Numbers like 2i. As long as I is in it, that constitutes an imaginary number. I, square roots of 3, that represents one number. That's an imaginary number. Negative 10i represents an imaginary number. 6i represents an imaginary number. But what about a number like this? Negative 5 minus 9i. The part of that number, negative 5, that's real. But the other part of that number, negative 9i, is imaginary. So this number is what we call a complex number. It has a real part and it has an imaginary part. So the number 3i plus 2 would also fall into this category. 3i represents the imaginary part of that number, and 2 represents the real part of that number. Same thing with 6 minus 3i, and same thing with 16 minus 7i. Now, these other examples that we have here, we got to think about them a little bit, about where they would need to go. They're going to require some simplification. Let's start with 3i to the second. I know that 3i to the second, based on what we've learned in our previous lessons, is equal to 3 times negative 1, because I to the second is equal to negative 1. So 3 times negative 1 is negative 3. When I simplify 3i squared, that becomes a real number. It might have started out looking imaginary because I was present, but the simplification process made it constitute into a real number. Same thing with I to the fourth. We derived the value of I to the fourth to be equal to 1. Therefore, I to the fourth is a real number, although it is disguised as imaginary until I simplify it. Let's check out 18i to the third. I know I to the third is equal to negative I, so this is the same thing as 18 times negative I, which when I multiply that gives me negative 18i. That's one value together. There's no sum or difference between a real and an imaginary. That 18 is attached to that imaginary. So this guy falls into the imaginary category. How about negative 8i, the square root of negative 8i? I've got to remember how to break that down. The square root's telling me to look for pairs. So I'd have to remember that this is the same thing as negative 1 times 8. The prime factorization of negative 1 we just learned is equal to I squared, which is I times I. 8 breaks down to be 4 times 2. 4 breaks down to be 2 times 2. So I'm looking for pairs. I got a pair of 2's. I got a pair of I's. Remember, my pairs come out front of my radical. So this would become 2 times I out front. And the only guy that didn't have a pair would stay underneath, which would give me 2. So this is 2i roots of 2. Now, is that real, imaginary, or complex? It's definitely not real. It's got an I in there. It's not complex because there's no adding or subtracting. This guy is all imaginary. So the square root of negative 8, which we know through our simplification, is equal to 2i roots of 2. I left off my 2. Would have to fall into the imaginary category. It's important for us on that milestone to know how to distinguish between what numbers are imaginary, what numbers are real, and what numbers are complex.